go over this cheat sheet one more time. One,
What? One more time.
we have your coplanar versus non-coplanar. Okay? So what I did was looked at the red plane versus the black plane. Coplanar, 4 points on the red plane, 4 red points, or 4 black points. Okay? Non-coplanar, 2 red, 2 black. Alright? Next, segment addition postulate. Okay? We're going to add these two, and they add up to be the whole. Alright? When we do that, we show the given. Do we then simplify by adding the like terms? We then start solving the equation, right? By SAD MEP. But in algebra, we call it the subtraction property of equality, division property of equality, and then we use our given to come up with the substitution method so that we can plug it back in and find AB. Okay? We know that an obtuse angle is an angle bigger than 90. We know that acute angle is an angle less than 90. And we know that a right angle is an angle that is equal to 90. If it bisects an angle, it's called an angle bisector. If it bisects a segment, it's called a segment bisector. In both cases, the angles formed, right, are equal. The segments formed are equal, okay, because it cut it in half. And then we've got, well, they gave you an angle bisector. You take that, you come up with your given. You come up with the definition of an angle bisector, meaning that the two are equal, which means that the two angles are congruent. Now you're able to substitute in whatever they told you the angles were, in this case 3x plus 2 and 5x minus 14. Again, we solve using subtraction property of equality, addition property of equality, division property of equality, and then we use the given to figure out how to substitute in what we got for x, and we solve using simplification, and now we have the angle. Okay. The next problem is a supplementary problem. Remember, supplementary is an angle, right, where we have, it's going to be two angles that form a line, right? So we've got supplementary, and then we have complementary, right? So we got two angles that form 90 degrees. Whatever it is, if it's supplementary, you draw the straight angles. If it's complementary, we're going to draw a right angle with an angle cutting it. We're saying that one angle is 3 times the other angle, so we're comparing two angles. So you use x for both of those. X on both sides. 3 times means 3 times the x, and 18 less means subtracting 18. Okay? So now I have the formula through the definition of a supplementary angle. Now I can use simplification to get my x's together. I can then use addition property to move my 18. I can use division property to move my 4. And that gives me 49.5 for the angle. To find the supplementary angle, we use the definition of supplementary angles. They add to be 180, so I subtract it from 180 and I get 130.5. And that's that problem. And then we have adjacent angles. Adjacent angles are angles that touch. Right? So if they touch, they're adjacent. If they don't touch, they're not adjacent. Okay? So angle 1 and 2 are adjacent and they create a linear pair because they're supplementary. Angle 3 and 4 are adjacent, but they do not create a supplementary angle, so they are not a linear pair. And any combination of 2 and 4 of the orange and the blue, 2 and 4, 2 and 3, 1 and 3, 1 and 4 are not adjacent because they don't touch. Okay? They don't create a larger angle. Next is perimeter. You add all sides, area, height times base, okay, length times width, right? All right, if we have 5 and 6 inches, then we're going to have 5 inches times 6 inches is 30 inches. That's your area. Perimeter, we're going to add up all the sides. So 5 plus 5 plus 6 plus 6 are 22. Okay. Now, if we have something where it's 3x times 4, or 3x on one side and 4x minus 2 on the other, we're going to create an area where we have 3x times 4x minus 2. We use distribution to do that. And we got 12x squared because the x times the x is an x squared. And minus 6x because no x times no x is still x. Next we have perimeter. So now we have 3x on both sides, that's 6x. 4x on both sides, that's 8x. 6x and 8x is 14x. And then we have the negative 2 on both sides, so that's minus 4. So you just simplification. Midpoint. You have the averages of two x's or the averages of the two y's. You have x sub 2 plus x sub 1 divided by 2, or y sub 2 plus y sub 1 divided by 2. If we have 2 points, 3 and 2, negative 4 and 8, I just take my 2 x's and divide by 2. I'll take my 2 y's and divide by 2. I get negative 1/2, and I get 5. That's going to give me the substitution and simplification. So I substituted in x and y, and I simplified it. Okay? Lastly, we have the distance formula. Distance equals the square root of y sub 2 minus y sub 1 squared plus x sub 2 minus x sub 1 squared. This can be very difficult to remember, so we're using flip it and smack it. Flip it, you have the y's over the x's, so I take the 2 and put it over the 3. I take the 8 and put it over the negative 4. I smack it in the center and in the center, all right? And then to rub it down, we got 2 arms, 2 legs, 2, a head, the plus sign, and the body. And that helps me remember all the parts to the formula. Okay? Flip it, smack it, rub it down. Now rub it down 2 arms, 2 legs, a head, and a body. If I keep remembering the whole part, it'll be much easier to put this in the formula than just plugging it into this formula. Especially if you don't have this formula available for you, like on the EOC. That formula was not available last year to the students. But they were able to remember, flip it, smack it, rub it down. So it helps. And also on the ACT. So, but then you have to use simplification. 2 minus 8. 3 minus minus, which is plus 4. So we have negative 6 and we have 7. We square those, so we have 36 and 49. We add those, we have 85. We try to break down the square root of 85. 5 goes into 85 17 times. 17 goes into 17 one time. Nothing comes up twice. So there's no way that we can pull anything out of the square root. And so the square root of 85 is done. But what if there was a way to pull out from the square root? So we use a different method. We're going to break down 96 just to see, have that on our test in case we get a number that can be broken down, right? So we break down 96 by using our smallest primes, 2, until we get to the next prime, 3, and then you go to 4, 2, 3, 5, 7, 11, right? All your primes. In this case, it was 2, 2, 2, 2, and 2, and then 3. And what we did is we looked for our pairs. We circle the pairs. For every 2 inside the radical, we get to take 1 outside the radical. That's what this is showing. 1, 2 outside, another 2 outside. But these stay inside, and so we're left with 4 square roots of 6. And just so you get a good grasp on it, we'll make sure we can see every portion of the cheat sheet. And then you can just pause it at home if you need to. Okay?
Are you
Because
posting on your YouTube tonight?
yes, I am. So this will be posted tonight on YouTube. And